Hello, everyone, and welcome to today's webinar, which is a joint presentation from BigML and Trifacta. My name is Paul Peterson. I'm from BigML, and I'm here with Victor Custanoble from Trifacta, and together we'll be showing you the power of combining data wrangling with machine learning. So a quick note about the format for today's webinar. During the presentation, you can enter questions you may have directly into the chat box of the GoToWebinar client, and someone from one of the members of our teams will do their best to answer them directly. And of course, we will also have some time at the end to field any remaining questions if you'd like. All you have to do is raise your hand and we'll unmute you and you can ask your question and we'll do our best to answer it. Also on this slide, you'll notice that we have our contact information if you would like to reach out to either Victor or myself with additional questions, or if you would like to schedule a follow-up discussion. I will give a short introduction to BigML, including a brief history of the company, what we've built so far, and the problems that we solve. And this will be followed by an introduction to Trifacta from Victor. And then we're going to get right into the demo, wrangling some data from Lending Club. So once Trifacta has tamed that data for us, we're going to load it into BigML and continue the demo by building a model to predict loan risk. So I want to begin by just taking a quick look at what the promise of machine learning is. And the basic idea is that, especially in today's world, most companies have data. Well, in reality, they have lots of data, right? We have data about customer data, customer behavior, about products, perhaps even data about the minutia of everything, thanks to the Internet of Things. And this is great. It's certainly better than having no data, but it's not what you really want. Instead, it would be great to be able to use that data to make decisions, to be able to reduce churn, or perhaps increase the conversion of your customers, or perhaps in a medical setting to improve the accuracy of a diagnosis, or in a financial setting to be able to reduce fraud, and so on. And the important thing is that machine learning is the tool that can get you from data to decisions, from information to insights. But why do we need machine learning? Aren't there other ways to do this? And to answer that question, let's just consider a really simple example. So here is a tiny sample of data, perhaps for a telecom company, that shows you, based on usage and customer behavior, which customers churn, right? So we can see the number of minutes they spent on the phone talking, the number of text messages, the number of purchases, their age, etc. And then we have the churn, which is whether or not they left the service. And the question is, just looking at this, can you find a pattern in this tiny data set? And even if you can, or if you can't, what tools would you use to answer the question for next month, which of your customers, based on their behavior, might churn? And even if you do see a pattern readily, the thing to understand is that this is a simple example. Whatever technique you imagined, ask yourself, would it scale to millions or perhaps billions of rows of data? Or worse, thousands or tens of thousands of features to describe your customer behavior instead of just the 6 that we have here? And of course, this is the power of machine learning. In the same way that it can be applied to this tiny data set, it can be applied to massive data sets with much more complicated features. And it can, for example, turn this data into a model which can, for a new customer, predict if they will churn or not. And so this is the power of machine learning. And now it may surprise you to discover that machine learning techniques are not actually that new. For example, classification and regression trees have been around since at least 1980. And all the recent hype around deep learning might make you think that it was just discovered. But the reality is it has also been around for decades. So why haven't we seen wide-scale adoption of machine learning before now? And there are many factors. And the first is just the sheer abundance of data that is easily available. Machine learning is useless without data to feed it. And in previous decades, data was hard to come by. But this has also been combined with the cost and the speed of computation. A lot of machine learning techniques were simply impossible in terms of computational requirements until fairly recently. Another critical piece is the maturity of these machine learning techniques. There's a lot of requirements to take an algorithm from the lab, where you're working with small data sets that are perfectly formatted, and make them work with large data sets that have real-world data in them. That is, they're messy and they're full of errors. But even with all of these pieces in place, there's still one critical factor missing, and that is the ability to apply machine learning easily. And so with this vision of machine learning made beautifully simple, BigML was founded in 2011. And since then, we have been building a platform which, the first piece, was a smart auto-scaling infrastructure, and it is responsible for maintaining a distributed machine learning backend capable of handling any task. And then, knowing that automation of machine learning would be critical, we wrapped this backend in a fully featured API. And this is important because it's very rare that you just have a one-shot machine learning technique, you go from data to model, and then you score and you're done, never do it again. The process tends to be very, very iterative, and retraining is a real thing. And so being able to automate with an API is critical. But we also understood that machine learning needed to be easy to use. And so we built a beautiful dashboard on top of our API, along with stunning visualizations that make it super easy to see what you're learning from your data and how you can improve. And we've also provided a suite of tools that simplify integrating machine learning into a variety of applications. And so this is the BigML of today. But even with all of this functionality, there's still a barrier to getting started with machine learning. You remember this slide? And how I told you that the promise of machine learning is that it is the tool that will take you from data to decisions, from information to insights. Well, let's talk about the reality of machine learning for a second. The reality is that most likely you do not have data, but rather you have crazy data. That is data that is spread across multiple systems, relational databases, CRMs, log files. Realistically, it's probably a mess. And this means that in reality, there's a missing step between the data you have and the data you need to perform machine learning, the so-called machine learning ready data. And it is tools like Trifacta that can help bridge this gap, transforming the chaotic data you have into a format ready to be fed into BigML to apply machine learning techniques and get insights. And so for today's demo, we're going to start with loan information from the peer-to-peer lending site Lending Club. And the insight that we want is to be able to predict which of the Lending Club loans are low risk and which are high risk. That is, the ones that are likely to default. And then to score all of the loans that are still in the marketplace and apply this decision-making process to perhaps select ones that we'd like to invest in. To get there, Trifacta will start with the raw data available from Lending Club and transform it to a machine learning ready format. And then we're going to put this data into BigML and use the machine learning to answer the question about loan quality. So now it's time for Victor to give us a little background about Trifacta and to kick off the demo.
Thanks, Paul, for this very nice introduction. So let me introduce you Trifacta briefly, 5 minutes, and after we'll do the demo. So clearly about who we are and what is the pain we are solving. So Trifacta, it's a US company, so based in San Francisco. We have office in Europe, London. I'm based in Paris. We have also people in Berlin, London. We are more 120 employees, created 5 years ago. First. And what are we doing? We are doing only one thing, very important. We are doing data wrangling and data preparation. So we are 100% focused on this problem of data wrangling and data preparation. So the goal of Trifacta is for different use cases, it can be BI, data viz, predictive analytics, to accelerate the time to value for business usage of your big data or of any kind of data you could have. Okay, to accelerate the access of the data and the cleaning of the data and the preparation of the data. And for this, you will see in the demonstration, we are providing a very visual interactive interface for self-service data preparation. So we do data wrangling and data preparation since 5 years. First, also something very important, what is data wrangling and what is the pain we are solving? So normally, if you do analysis, predictive analysis, data viz, you spend common things in the market, you spend majority of your time, between 50 and 80% of your time, spent on data preparation. Okay, so data wrangling is all this step. You have question, you have data, lot of question, lot of data. You want to create model, you want to create reporting, data viz, but between this question and this analysis, you need to do what? You need to discover your data. You need to explore your data. What is your quality of my data? You need, when you have some messy data, you need to structure this data. Data, for example, coming from log file, from JSON, XML, etc. So you need to create a clean structure for your analysis. You need also to clean your data. I can speak about missing data, mismatch, all the dirty data you can have in your incoming files. Okay, you need also to enrich the data. That means that you need to combine different data sources. You need to do aggregation. You need to pivot. You need to do lookup, etc. So you need to mix all this data on the same layer to do analysis. And at the end, Trifacta, in the data wrangling process, you will publish the results. You will see that into a nice format, clean format for analysis. So this is data wrangling. So Trifacta, we are providing a solution on top of big data or Amazon environment or Google Cloud environments. The goal for Trifacta is to give an access for business analysts. So it's a self-service access for business analysts, data scientists, data analysts, give access to raw data under the control of IT. It's very important. So IT control, store, and secure the data, but the business user or data analysts or data scientists need by themselves to access the data, to explore, structure, clean, enrich, and publish the data so it can be for reporting, for BI, data viz. In this case today is for predictive analytics. You can do also machine data. For example, you can analyze, you can wrangler, and you can prepare data coming from IoT, log file, etc. So Trifacta is focused on this part. It's a solution on top of your platform to access the data and to clean and prepare the data. So what is a key differentiator? You will see that in the demo, but we provide a visual interactive interface. It's very important. We give to the business user a real-time feedback when you do something. It's allow you to remove all the iteration. Okay, so each time when you do something, you will see that in real time, you see the impact, you have a preview of your transformation. Very important. We also provide predictive transformation. We suggest transformation. That means that when you do something into the interface, Trifacta, we have a predictive engine allowing us to suggest and to predict the next best transformation step. Okay, so we provide you some suggestions for the join key, we provide you suggestions for the regular expression if you want to extract a pattern, etc. So it's a visual interactive interface with suggestions, with prediction for the transformation. The last topic is very important, is more on the IT side. So we completely integrate into your existing infrastructure, into existing big data platform or IT server, etc. Okay, so we really rely on your existing infrastructure. We don't store the data, so we can be plugged into any big data, Amazon, Google Cloud, or relational database to be able to connect to your system and to do this data preparation. So this is a key differentiator. You will see that during the demo. We are recognized as a leader in this term. Okay, if we go to the analysts, for example, people like Dressner or Forrester, in the last wave of Forrester, we are one of the top data preparation tool. In terms of customer, you can find, so if you are interested, you can go into our website. You will find different use cases like PepsiCo, Linkit, GoPro. We have people now like HSBC in finance using our solution to prepare the data, to clean the data. Okay, and as you see for our partner, so we have a lot of partners now, BigML, but a lot of partners in the IT side or BI side world, okay, like Tableau Software or Google Cloud, Hortonworks, etc. Okay, so really we are focused on this data preparation and data wrangling problem. So the goal for Trifacta is to solve the pain of preparing the data, to reduce this time, this 80% of time to prepare your data before any analysis. So I think it was clear. You will see that in the demo. So again, as already Paul say, so the goal in this demonstration is from Landing Club data to create predictive low risk model. We're going to optimize the investment strategy. And for that, we're going to do basic data wrangling that creates two data sets, one for the training with closed loans, okay, and another one for the prediction, for the scoring. So we're going to do scoring on top of open loans, okay. Something also I want to add, it's this predictive modeling data pipeline. It's an iterative process. Okay, so you have all your data stored somewhere. You do preparation to do your training, okay, to train your predictive model. Then you will apply this model to do scoring. During certain period of time, you monitor the score, and if there is something wrong, you come back. You need to prepare again your data, do a training, etc. So it's very iterative, okay. And during this iterative process, you need to prepare the data, train your model, etc. Okay, I think it's enough for the slide. So let's go for the demo. Okay, so this is a Trifacta interface, web interface. So I have a flow, it's like a project. I have data sets, so I can import my data into my environment. I can drill into my Hadoop cluster here, into S3 from Amazon. I can go into Hive table or relational database like Teradata, Oracle, etc. Okay, so I connect to my data, right? Now I have flow. So flow is like a project, I say. So let's go to the insurance loan flow. Okay, I have three data sets: loans. Okay, we will see that the history of the loans, member, and the loan purpose. Okay, let's begin with the member. So here it's a file, classical file, txt or CSV. So I'm going to add a receipt, a script. Okay, so let's edit the receipt. What's happened? When you first open any file in Trifacta, first, Trifacta, we try to understand the structure. What are the rows? What are the columns? Here it's simple, it's a CSV file. Okay. We guess also the type. It can be a simple type, it can be a more complex type. You can add also your custom type based on a pattern or based on a dictionary, okay, a business type. Okay, based on this type also, we understand the quality of your data. So here in green, it's valid data. In gray here, it's a missing value, and in red, it will be the mismatch. Okay, here it seems that everything, there is no mismatch. Great. We guess also the distribution of your data. As you can see here, I have the distribution depending of the year. Okay, so for example, if I go here into my state, okay, if I go in details, here I have a map because it's a state, okay, but here I go more in the annual income, okay. So here for the income, I can see some statistic, the outlier, the mean, the max, the value, the histogram, etc. Good. Now I want to begin to wrangle the data, to prepare the data. So for example, here into my title, I have some missing value, right? I would like to fill this missing value. What I can do, I click on missing. Automatically, Trifacta suggests transformation. Hey, I want to replace the missing by something. I click on missing. I have a preview. I modify the step, and I say when I have nothing, please replace by missing. Okay, so now I have missing. Good. Now I have here, I want to extract the date. You know, it's 9 years, etc. So why not to extract in a simple way? Okay, what I can do, I can select, I can brush 9. Automatically, Trifacta suggests transformation. Here, I want to extract. I don't want to extract just 1 digit. I want to extract 2 digits. So here, I have another suggestion to be able to automatically, based on the pattern, extract the 2 digits. Okay, and here I can rename this as, for example, so this is my AMP years. Okay, good. So I did that. And so, for example, here I have some missing. So I have also a menu here, for example, to be able to clean, to filter, to do aggregation, structure, etc. So here, let's do some simple things. From the missing, I want to remove, to delete all the row missing. Okay, is missing, delete. Right. The last interesting here for my predictive model, I want to compute the average of the income per state, because the annual income it can be different by state. You know, the average is not the same if you live in California or in other states. So here, why not to select income, okay, and I will also select the states. I select 2 columns. Right. Now Trifacta suggests transformation. Do I want to drop, to aggregate, to create a new column? Here I don't want to aggregate, but I want to create a new column. You know, it's not a group by. I want to keep the details. So I want to create a new column with the aggregate by state. Okay, so here it's a create a new column. Okay, here, so if I select this, I have the sum. It's not the sum. Okay, I want the average. So I select average here, and here I say, let's select the average. Yeah, here I have the average. Okay, great. So I do that. So let's go quickly for the loan. Okay, so something important here on the right side, you have a script, you have a receipt. Each time I did something, I have a step, I have a transformation, okay? And at any time you can undo, you can come back, or you can come back to any stage, okay? You can edit, you can insert a step, etc. So as you can see, it's an iterative process, okay? You come back, you edit, you play with it, right? So if I go to the loan, and I will do a join, so here, okay, I have different information. I have my loan. If I go in column, oh, I have a lot of, here I have a lot of gray, red, okay? So I can show in grid. Yes, it's because if I see the mismatch, okay, it's because I have a decimal. So why not? In one click also, I can select all my column, all this column, okay? and I can decide for this column, okay, automatically to change the type and to go in decimal. Okay, so now everything is green. Okay, this is good. Something here, I have a code. I want to replace the code by something, okay, for my predictive model. Why not to do a lookup to replace the code, okay, by something, by the lone purpose. I select it. Here I have the code, okay. So here, instead of a code, I must have somewhere, okay, my description, okay. So I fill it where it is. Anyway, so here, okay, I have the title. Yeah, the description. Okay, anyway, so here I did a lookup to have my my description. Okay, so here, sorry, it was here. So lookup, sorry, on purpose. Okay, based on the code, I do that, execute the lookup. Okay, so now I have the description. Last interesting thing I want to do a join. Okay, I want to join this loan with my member. So I do join. Okay, here I select my member data sets. Okay, so based on the content of the column, Trifacta suggests transformation. So here Trifacta will find the member ID. Okay, I can do left join, a right outer join. I can do join on multiple key. I can do also what we call fuzzy join. Okay, ignoring the case, etc. So good. Let's take all the column from the loan and from the member. Okay, so now I have this, and I have a script again with everything. Okay, so if I come back in my flow, so now I have a flow with here the scripts with a join, with a low purpose as a lookup and the member. Okay, and now to create my data set for BigML, why not to create a new receipt? Okay, two receipt, one receipt. I will do that only one, but one receipt with the open and one receipt, okay, with a close. So if I take this one, okay, so here for the close, okay, so in fact I just have to go in loan status, okay, and depending on some value, okay, so my loan status must be somewhere, sorry, so here up I can go here and here status, okay, loan status here, let's go here. Where's my loan status? Loan amount. Oh, okay. Yes, here, sorry. So here I will select the current, okay. I want to remove the current, so I select the current, I will select the late, I will select the ingrace, okay, and say I want to remove these open loans to keep only the close, okay. So let's delete these currents, okay, right. And now I have a data set ready for BigML. So now the last thing, I have to run job, okay? So I run a job to apply this at scale on your billion of data, okay? So if I run a job, what's happened? At the end, I will have a flow like this. So creating the loans and the open loans, okay? And the result is what? The result of the job is this, okay? So at scale, on your million of row, you will have the profile and the statistic on everything, okay? And at the end, again, I can export the result in HDFS, in S3, on Amazon, or publish this in a Hive table for analysis, okay? So this was my demo. So let's come back to Paul for the BigML demo.
Thanks, Victor. The rest of the work is up to me. So now we need to take these files and the closed loans and the open loans, and we're going to use the closed loans again to build a model that basically predicts the default, or what essentially the quality of a loan. And then we're going to use that model to score all the open loans. So the very first thing we need to do in the BigML platform is we need to get these files that have been produced by Trifacta into BigML so that we can continue the analysis. And to do that, I'm actually going to use what we call a remote source, which allows me to create a source directly from an S3 bucket. And in this case, I'll just give it a name. We'll call this closed loans because that's the file I'm pulling in. And so just by putting in that S3 link, Trifacta can write out to S3 and BigML can read directly from S3 and pull this file in. Now there are other integrations. So actually I have the open loans in my Dropbox account. And so for example, I can use our Dropbox integration to pull in the data as well. And so I'll pull in the open loans from here instead of using S3 for that one. All right, now if we look at the closed loans, the first thing you'll notice is that we've rotated this view 90 degrees, and this is just I'm just mentioning that in case it's confusing at first, why this is rotated. But the idea is basically that each column is now a sample of data from the source, and this allows you to paginate through the features. So if there happens to be, say, 10,000 features or something, this one actually has 76, but you would be able to paginate through them, which is a little easier when you have thousands and thousands of features, perhaps. So the important thing about the source step is just to take a look at what BigML has done in terms of auto-typing the fields. So we take a little peek at the file, and we try to figure out what all the field types are. And the idea here is just to make sure that they look correct before you go to the next step, which is what we call our data set. And this one has done quite well. You can see we've got a mixture. Here's the description field that Victor was building for us. It came up as a text field, so that looks good. Here's the loan quality field that we built, that Victor built for us, which has the good and bad loans marked in there. That's the field we're going to predict. And then we also, so that's a categorical, and then we also have numeric fields like the interest rate and the funded amount, the loan amount, this kind of stuff. Okay, so from the source step, this looks okay. Let's go ahead and just go to what we call our one-click data set. And this is going to take those field types and use them to compute the summary statistics. And in a way that's similar to Trifacta, we're going to show you the distributions. The difference here is that the histograms that we're showing you in the dataset view is meant to be a pre-flight check for the machine learning. So if any of those field types were incorrect in the source step, or if any bad data came through accidentally, or in this case, you'll also see some fields marked with a red exclamation point. This is a heuristic we have that tells you that those fields are probably not useful for predictive analytics. And so that's what this view is for. It's just for, again, a pre-flight check, making sure your data looks right. We can see the count of the fields that are in here, the number of missing or errors. And for each of these fields, we can see a nice distribution for the values, right? So here we can see we have loan amounts from 1,000 all the way up to 35,000. We can see there's only two types of terms, 36 months and 60 months. And for the text fields, we can see a tag cloud representing the token frequency of all the words that are in there that borrowers have used to describe the loan, right? So we can see the credit, consolidate, cards. These are all very dominant reasons that people are describing why they want this loan. All right. Now, all we need to do to build this model is actually just to configure the model and tell it the field that we want to predict. And so in this case, that actually is the loan quality. And we'll just go ahead and let this run. And this is going to build something called a decision tree. It's one of several different types of supervised models that BigML provides. It's actually quite powerful, but has the advantage of being very, very easy to visualize and understand. So it basically creates these rules for you. So you can see that at the root of the tree, it's splitting on the interest rate. And if we go down a few branches, we can see some bounding on the interest rate and another field that actually I don't remember what that abbreviation stands for. But we can see that in this particular branch, if you meet all those criteria, that this would be predicting that this is a good loan, a good quality loan with a confidence of 98%. Now, however, if you look at this, though, we can see it's making splits on interest rate, which perhaps isn't very interesting, pardon the pun, because that is a market-determined value. And so you can imagine that there's a pool of users that are submitting these loan applications. There's another pool of users that are reviewing them. And the interest rate is part of the decision of the loan quality. And so this is sort of leaking information. Having a model that builds these predictions based on the interest rate is basically just relying on the market to assess the loan quality for us, which isn't really what we want to do. We want to do something a little deeper. We want to be able to replace the human analyst. And so what we can do is we can go back to our data set and take that feature out. We don't actually want to use the interest rate when we build this model. So let's go ahead and do that. We'll take out the interest rate, so we won't use it for making predictions this time. And similarly, we'll take out the grade and the subgrade because those are also market-determined factors of loan quality. So we don't want them in there. And now there's one other little trick that we're going to do, which is that if you look at this loan quality field, that this is what's called a very unbalanced class. So there's very few bad loans and there's quite a few good loans. And one of the things that can happen is that the model will basically overfit to the good loans. And so you have a model that does very well predicting good loans, but doesn't do very well predicting bad loans because there just aren't enough of them. And we can fix this quite easily using something called balance objectives. So if we come all the way back up to this weighting, we can just select balance objective. And this will force the model to treat both classes similarly, even though they're unequal representation in the training set. All right, so let's go ahead and create this model with those changes, taking out the market-determined forces and allowing the objective to be balanced so that we get an equal loan consideration. Okay, so now we can see we get a split based on the term, which is interesting, and a 36-month loan. The next split here is on the debt-to-income ratio. If the debt-to-income ratio is low, right, 7% or so, we can see that this is predicting a good loan with a high confidence. This matches our intuition. It's nice. But the important thing to remember about is don't confuse intuition because the machine learning algorithm is finding these patterns just by analyzing the loans. It doesn't have any intuition about what DTI, it doesn't even know what DTI means. Okay, and we can see similar that coming down here, we have splits on whether or not the description contains the word balances or charging, and the number of mortgage accounts is less than 6, and the debt to income ratio is additionally bounded by 3. The employment title doesn't contain school and doesn't contain Kaiser. I'm not sure if that's a city. It's an employment title. I don't know. But anyways, if you meet all of these criteria, then we're predicting a loan with good quality at a 93% confidence. So this is our model now. And you can imagine, for example, that I might want to repeat this. Maybe tomorrow I run a new batch of Lending Club data through Trifacta, and I get new source files, and I want to rebuild this model, and I want those same settings. I want the interest rate not there. I want the balancing. Maybe I do something with a boosted trees or an ensemble method that's a little bit more sophisticated than the single tree. But the idea is that I want to be able to repeat this workflow with new data every day. And so we can actually do that very easily with this script-defined model. And this will actually create a what we call a WisML script, which will repeat the entire workflow that I just executed from the source to the data set, to selecting the features, to building the model. And I'll be able to input a new source into this script and re-execute all the steps, no matter how many there are, even if there was a batch process in the middle of it. All right, so you can see all I need to do is put my S3 link back into here, and well, actually I can just do that, and then I can hit execute, and it'll rerun that entire workflow. So this WisML combined with Scriptify is a very, very powerful technique for automating these machine learning workflows. And other than writing your own, there actually are quite a few that are available in the gallery as well. And so that actually is a worthwhile place when you're trying to solve a specific problem to come out to the gallery and see what kinds of scripts are being shared out here that might solve the problem you have. For example, if you're working with an ensemble, here's one that will actually find the best hyperparameters to optimize your ensemble so that it performs the absolute best it can for your specific data, right? You can imagine there's lots of different ways you can configure that ensemble, and rather than guess, you can run this tool and discover the best features. All right, but there's several other tools that are available out here. And again, I can take any one of these scripts, clone it into my gallery, and now I have added this ensemble optimization feature to my account. All right, in a similar way, I can actually take this script that I just built, my script for closed loans data, and I can actually put this into my my dashboard settings. So I come up here and I can say, okay, here's the sources, and I can actually add this script into the, well, actually, it's in the remote sources. Anyways, I'm running out of time, so we'll speed this up a little bit. But you can put these scripts directly into your dashboard, and then once you do that, you've changed the configuration of the dashboard so that you have these one-click actions as part of the interface itself. All right, but let's go ahead and finish scoring the loans. So we'll take the open loans now, and we'll do the same thing. We'll just take a quick peek. We can see, oops, the description is meant to be a text field, so let's fix that. It misses that one periodically. So this is an example of using the sources correctly. So we'll change the description to be a text field and update that. And then we'll do all I need to do here is create a data set from this now. So we'll do a one-click data set again. And now I can take this data set of these open loans and I can score them with my model, and I can output this as a CSV. So we'll go back to our model, and we'll take this closed loan data set model, and I'll do something called a batch prediction. And now I can take the open loans. This is the data set of all the Lending Club loans that have not attained a final status, or they haven't been fully paid or defaulted. And I can hit predict, and this will take each one of those loans, run that through the model, predict what the loan quality is, and I output either a data set or a CSV that we can examine. So we can download this batch prediction, and I'll have a CSV on my local computer that now has all of those loans along with the predicted loan quality. All right, so yes, here we go. So here we have the member ID, the loan amount, and you can see in the last column out here, whoa, too far, is the loan quality prediction. So there we have some loans already that are being predicted for good or bad. All right, so as we've seen today, with BigML and Trifacta, you have two of the best of breed solutions. So Trifacta with its easy to use data wrangling capabilities, and BigML with its ability to make machine learning beautifully simple. And with both, you have a solution which is easy to use, which encourages self-service and a wider adoption within your company of these powerful analytic tools. Both solutions are scalable and interoperable. That means that they are comfortable working together as well as with other tools in a seamless way, and also make it possible to do automation, right? The whole idea of automation, repetitive tasks, it's very, very important. It's very rare that these solutions are just going to be one through and you're done. Okay, focusing on automation is very important. They both make repeatability and collaboration not only possible, but actually quite fun. I didn't show you, but there are ways, and I know there's in Trifacta as well, where you can take all of these models, or you can take these processes you've built and you can share them, right? Actually, a little bit in the WisML gallery, you can create these core execution units and you can share them and other people can use them as well. And so that level of collaboration is a very powerful feature. And of course, they're both cost effective. So by bringing BigML and Trifacta together, it makes it possible to go easily from the data you have to the decisions you want.